Welcome back. We are now continuing from Unit 1, Session 2, Permutation of whole set and subsets. At the end of this lesson, what will you look forward to? We should be able to explain permutation as principle of counting, give examples of situations that require the use of permutation, state and apply the factorial notation in permutation, and apply permutation as a counting principle. Let's set the ball rolling. Permutation. When you talk about permutation, what does it mean? Permutation is just an arrangement of elements or objects where order in which they appear are very important or very necessary. Yes, the order in which the arrangement appears are very important. Maybe with an example, you're able to get the concept clear. Example 1. Assuming that we are supposed to arrange a set of X containing elements A, B, C, and we are taking all at a go. Now, what are the different arrangements we could have with that A, B, C? Well, the different arrangement will be A, B, C as one, A, C, B as another one, B, A, C, B, C, A, C, A, B, and C, B, A. Can you think of any other one that have not been captured? Well, that could be it. So what have you noticed from this? You've noticed that arranging n different objects, taking all at a time, will be equal to n factorial ways. N factorial ways. What do we mean by n factorial ways? Well, that is by the multiplication principle. The number of ways of arranging n different objects taking all at a time is n factorial ways. And n factorial could mean that n times n minus 1 times n minus 2 times n minus 3 up to the last number 1. You get it? So for instance, if we said 6 factorial, so 6 factorial could be equal to what? By the multiplication principle will be 6 times 5 times 4 times 3 times 2 times 1. Now, referring back to the equation above, as we have the set A, B, C to arrange. Now the question is, what is the total element in that set? It's 3. So in how many ways can we arrange this? That would be n factorial way, because the total is 3. So it's 3 factorial way. And what is 3 factorial? 3 factorial equal 3 times 2 times 1, and which equal 6. That's the permutation of a whole set. Let's make progress. What if you want to talk about permutation of a subset? Now, suppose we have n different objects and we are to select r number of them or arrange r number of them at a time. Then this could be written as you could see, n permutation R. N permutation R. You have n different objects and we are arranging R number of them at a time. You're not taking all, so that could be n permutation R, which equal to n factorial all over n minus 1 into brackets factorial. You get it? And you know how to work on factorial analysis or how to break down factorials. So let's pick example 2. Example 2. Find the number of permutation. Find the number of permutation of 5 letters taking 3 at a time. Taking 3 at a time. Find the number of permutation of 5 letters taking 3 at a time. So in this case, our n will be equal to 5 and our r is 3. By the use of the permutation formula, we're going to have 5 permutation 3, and this gives us 5 factorial all on 5 minus 3 into bracket factorial, and 5 minus 3 will give us 2. So we'll have 5 factorial on 2 factorial. And now 5 factorial is 5 times 4 times 3 times 2 times 1, and all over 2 factorial, which is 2 times 1, and this will give us 60, as the 2 can cancel and the 1 can cancel, leaving 5 times 4 times 3 giving us 60. You got it right. Maybe let's work on more example. Example 3. In how many ways are there for 2 students in a class of 10 to give presentation, taking the order in which they present into account? Again, this is permutation. How do we know? Because the question specifies that taking order in which they present into account. And as we said earlier, permutation have to do with arrangement, where order is very important. So with this task, what will be our solution? Ideal solution. So we could identify that we have n to be 10 and r being equal to 2. So that will give us 10 permutation 2. And that will result to 10 factorial all over 10 minus 2 all factorial, giving us 10 over 10 factorial over 8 factorial. Now there's one interesting thing about factorial. For instance, 10 factorial could be equal to 10 times 9 times 8 factorial. Why do we end with 8 factorial? You know, we're supposed to break down till we get to 1. But when we stop on the way without getting to 1, we need to bring the factorial sign. It means that we can continue from 8 going. You see, now why would one choose to end at a particular number and bring the factorial without getting to 1? Possibly to make the work easier by way of cancelling. So you see that I have 10 factorial over 8 factorial. So 10 factorial will be 10 times 9 times 8 factorial. In that case, I could cancel the 8 factorial over the denominator's 8 factorial, leaving me with 10 times 9 all over 1, which is the same as 90. So in this case, it means that the 2 of the 10 students can present or can make their presentation in 90 ways. I hope you can work on one example. Thank you very much.